Now we are going to discuss the total angular momentum. Total angular momentum of electron. We know that we have two types of motions of the electron around the nucleus. The first one is orbital motion. The second one is spin motion. If I further tell you, this orbital motion is responsible for diamagnetic nature, and the spin motion is responsible for paramagnetic nature, and for some special types of elements it is also responsible for ferromagnetic nature. This nature is called universal. So let us come to our topic, orbital motion. And for this orbital motion we have orbital angular momentum, which is called capital L. Its value in magnitude is given by under root L into L plus 1 h cut. And for spin motion we have spin angular momentum S, and value of S is under root S into S plus 1 into h cut. Okay, so the combined electron momentum, total angular momentum is vector sum of L and S. It is represented by J, which is equal to vector L plus vector S. This is called vector J, total angular momentum of the electron. Okay, so corresponding to orbital motion we have orbital angular momentum, and we have orbital magnetic dipole moment. Similarly, for spin angular momentum we have spin magnetic dipole moment, and corresponding to total angular momentum we have total magnetic dipole moment. This orbital magnetic dipole moment is represented by mu L, and spin magnetic dipole moment is represented by mu S. Similarly, the total magnetic dipole moment is represented by mu, or some of the books call them mu J. So let us discuss mu L, mu S and mu J one by one. The derivation is given in the books. We can simply discuss the value, which is equal to minus E upon 2m into L. Clearly, the direction of mu L, since it is a vector quantity, its direction is opposite to the direction of L. This E by 2m is a constant quantity because charge of electron is constant, mass of the electron is constant. What is the value of charge? E. E by 2m is a constant value. So if I completely write the expression, we have to further add an element. This GL is called orbital G factor. It comes from the experiments that value of GL is 1. So there is no difference between this and this expression. In magnitude, the value of mu L can be written as, see, we already know that the value of L in magnitude is L into L plus 1 square root into h hat. If I put this value here in magnitude form, we have minus GL E upon 2m L into L plus 1 square root into h hat. I can combine this E upon 2m with h hat. So we get minus GL E h hat upon 2m L into L plus 1. So the magnitude comes out to be minus GL mu B under root L into L plus 1. Here mu B, whose value is E h hat upon 2m, is called Bohr magnetone. The value of mu B is 9.27 joule per Tesla. Okay. So this is the value of orbital magnetic dipole moment. Similarly, we can find out the value of spin magnetic dipole moment. Spin magnetic dipole moment. Its value is mu s is equal to minus gs E on 2m into s. Here gs is spin g vector, s spin angular momentum. The value of s in magnitude is under root s into s plus 1 square root into h hat. H hat is what? H upon 2 pi. Here h is Planck's constant. So in magnitude we can write value of, okay, gs from experiments, it is found that value of gs is equal to 2. Value of gl was 1, the value of gs is equal to 2. So in magnitude, if I write, we can write minus gs E upon 2m magnitude of s, which is equal to under root s into s plus 1 square root into h hat. Again, we can combine h hat here. We can write it as a Bohr magneton. So the value of mu s comes out to be minus gs mu b under root s into s plus 1 in magnitude. So this is all about the spin magnetic dipole moment. So now we can switch towards the total magnetic dipole moment. We can call it as mu j. Its value is gj E upon 2m into j vector. Here gj is called Land's g vector. Forgive me if I spell them mistakenly. Okay, the value of gj is equal to 1 plus j into j plus 1 plus S into S plus 1 minus L into L plus 1 upon 2J into G plus 1. So again in magnitude we can write mu J is equal to minus Gj E upon 2M. The value of J in magnitude is J into G plus 1 square root h naught. Here J is total quantum number. Okay, we can write it like J into G plus 1 h naught mu J is equal to minus Gj so we can combine again here E h naught upon 2m as over magneton mu b J into J plus 1. So this is the total magnetic dipole moment. I can write all the formulas once again here. Mu L is equal to minus GL E upon 2m into L. In magnitude, mu L value is equal to minus GL mu B under root L into L plus 1. We have mu S is equal to minus GS E upon 2m into S, and its magnitude is minus GS mu B S into S plus 1 square root. Similarly, total mu J is equal to minus Gj E upon 2m into J is equal to, in magnitude we can write it, mu J is equal to minus Gj mu B under root J into G plus 1. We have to keep in mind all these formulas, especially the magnitude one, to find out the numerical problems. So with this we are done with the magnetic dipole moments.